Fantastic stuff. Okay, everybody, thanks for coming out. Welcome to AI and Deep Learning for Enterprise, a meetup all about applied AI. A couple of quick bits of housekeeping before we get into this evening's presentations. So if you're looking for anyone to give you a bit of help whilst you're here this evening, we've got three hosts, myself, Ben and Kevin. Ben's from Capgemini and Kevin is from Demon. I am an organizer at the meetup. We've got three fantastic talks this evening. We've got Henry Musto from Goldsmiths talking about artificial intelligence in Alzheimer's modeling, challenges and missteps. Jackson Gabbard from Cord, who's talking about why embedding vectors are so absurdly useful. We have Ruby Stoddart from Datasparq talking about scalable optimizations of a dynamic pricing model. And I think she's around here somewhere. Cool. So a quick bit of housekeeping right up front. Would you like to talk at one of these events? Don't be put off. Well, we know we have some really exciting talks from some really cool people. But if you feel like, oh, that is not the right slide. Hello. There we go. Cool. If you want to talk at one of our events, do drop us a line. We're more than happy to help people who are first-time speakers with coaching, stuff like that. So do give us a shout. Secondly, we have a code of conduct. Long story short, we want to create a safe and welcoming community for everyone. We want to make sure things are professional, if friendly, and we always want to treat our hosts and our venues with respect. You can see the full version of that via that QR code. But yeah, thank you everyone for doing your best to make this a welcoming environment. So now I'm going to hand over to Kevin, who's going to talk a little bit about our sponsor, Demon.
Thank you. Hi everyone, and thank you for coming out on this this evening to the lucky number 13 of AI and deep learning. So just a bit about Demon. It'd be remiss of me not to give you some background to who we are. So we are a digital transformation agency who I think we're different in that we put people front and center of everything we do. So whether that's software engineering or cloud migration, or AI and machine learning, we put the human beings front and center of that. And I personally think that's what makes us a great place to work. So obviously a bit of a sales pitch for how good we are as a company, but we won a number of awards in 2022 and grew that number in 2023, winning 4 awards, including Outstanding Work, Top 25 of the best companies to work for in London, and we hope to grow that number in 2024 as well. We have a number of clients across many industries, public sector, startups, all the way through to FTSE 100 companies like Sainsbury's, Walmart, Specsavers. We do work across a number of different practices. Obviously, AI and machine learning is one of the key things that we do. Part of it is because it's interesting. We take on projects not just because they're good for business, but actually because they make Demon a more interesting place to work. Which, going on to my final point, my presence here isn't entirely altruistic. We are hiring, and we're always looking for the best and brightest talent. And we do have openings. If you are, any of you looking for openings somewhere like Demon, please go on our website. All of our openings are on there. We have a range of different roles on there. Different skill sets, different entry levels. So data engineering, I know we're looking for cloud engineers, software engineering consultants and DevOps consultants, but we're updating that all the time. So if you are interested in changing career or looking at working somewhere slightly different, then please look us up. Just want to say thank you so much and enjoy your evening.
Hello, everybody. Welcome to Capgemini. Hello, I'm Ben. Thanks for coming. I won't take up too much of your time. Just welcome to Capgemini. For those of you who need the toilets, they're just round to the right. And you're in the AIE, which is the Applied Innovation Exchange. So we're part of quite a big company, Capgemini, but our Applied Innovation Exchange kind of focuses more on discovery projects and kind of building out prototypes that we test. A lot of that has been AI-led recently. If you would like to know any more about it, I'm more than happy to talk to you. I think I won't take up too much more of your time, so just happy to get on with the evening. Enjoy the event.
So one final thing before we kick off, we're trying to create a slot for community announcements. So if you're an academic in the field or you run a meetup, give us a shout. We're always happy to promote other people's events. And we have a quick word from Atazi at the back.
It's my first time talking, so I'm a bit nervous, but basically I'm conducting a research in AI governance, and AI governance is a framework of rules that companies use to conduct AI practices in their companies. And currently, this field is being widely researched across the world. So London has pretty set frame of rules and ethical practices that companies should follow. But they are researching more into it. So I am conducting a research for my university that is that involves AI governance. So I would be really happy if anyone would like to participate. And I even have leaflets that explain everything. So if you want to have a look at them, they will have all the information. But yeah, basically it's a 2-month research. But it could be less, so I'm trying to do it really quickly, so I don't take much of your time. But yeah, it involves one interview. It will be one interview that will be a maximum of 20 minutes. And then 30 quizzes, ideally, from people working in the company. So sorry, in case I haven't said it, this is targeted for companies using AI or anyone working in AI. So it will be a survey of 20 minutes and 30 quizzes of 5 minutes maximum. So it shouldn't be long, it shouldn't supposed to take much of your time, but it would be really useful because London is currently researching the best ways to carry out AI governance, and this will be a positive impact for London and for the UK in general, because the UK is currently the government is currently researching it as well. So yeah, that's pretty much it. So yeah, I'll come to me and I will give you this.
Cool. So without further ado, I'm introduce our first speaker of the evening, Henry Musto.
Okay. All good? Yeah, great. Hello. My name is Henry Musto. I am a part-time PhD student going into halfway through my 4th year, researching artificial intelligence applications for the prediction of dementia in general and Alzheimer's in particular. For my sins, I am also a full-time data scientist and have worked in various industries. And as a result, I don't sleep very well. So I just want to thank you for inviting me to do this talk. I don't know if anyone remembers the talk at the meetup a couple of months ago when the head of AI for WPP was here. That man is a force of nature. I was sitting at the back, like ordering all the books he was recommending. So it's a significant honor to be presenting in the same space. Now, I will be talking about, let's go back. I will be talking about the challenges and missteps within the translational artificial intelligence for the application for prediction in dementia research in general and Alzheimer's in particular. Now, there are a number of challenges which have meant that currently there is no single model which has been successfully embedded within healthcare research, but in relation to dementia, and I will be discussing a few of those. Now, in terms of how far can I walk before I go out of camera shot? Can I walk at all?
You can walk. What I can do is I can come over and follow you with the camera.
No, that's weird. Let's not do that.
Yeah, it goes all the way to the other side.
Even better. Ignore me.
You're good.
Sorry, I have a habit of pacing. I'm going to try and stay here, I think.
You're good to pace.
Now it feels weird if I do pace, so now I don't know what to do. Okay, so artificial intelligence, like in a huge amount of industries, artificial intelligence, machine learning, deep learning, whatever you want to call it, they're all PR terms. They have been successfully embedded in things like your phone, recommendation systems, in Netflix and Amazon, and so on. And the applications have only grown with the introduction and widespread usage of things like ChatGPT and other large language models. One industry where we would hope that it would have the most important, let's say, application would be healthcare. Unfortunately, this industry in particular has lagged behind other industries in the successful adoption of artificial intelligence models in order to predict and meet challenges related to, disease progression, disease predictions, disease prevention, and so on. However, there has been a long history of statistical modeling within healthcare, and this is called clinical prediction modeling. And there are four main areas for clinical prediction modeling which have been around for decades. The first is the fundamental prognosis research, can't read my own slides, where we look at a population as a whole. You all remember from COVID, we track the progression of a disease throughout the population. We track the vaccine uptake. We build models to try and predict, when we got enough vaccines so that we can all come out of our homes again. Another aspect is the exploration of biomarkers as a potential for predictors in building these artificial intelligence models. So most recently within my domain, we have moved away from biomarkers derived via lumbar puncture, extremely invasive and painful, to more blood-based biomarkers in order to predict who is likely to go on to develop Alzheimer's disease. The exploration of these biomarkers, candidate biomarkers which will be less invasive, easier to collect, is another aspect of clinical prediction modeling. There's also prognostic model research, which is predominantly what I do, which is predicting who is likely to go on to develop a disease. And most of my work up to now has been predicting the risk of developing the disease, Alzheimer's disease, as a function of time. We will discuss that in a bit. And then there's also using that prognostic modeling to inform treatment decisions, diagnoses decisions, differential diagnoses, and so on. I have gone backwards. Now, let's talk about the domain in general. So dementia is an umbrella term for a number of syndromes, of which Alzheimer's is the most common, with between 60 and 81% of all dementias being of Alzheimer's type. Now, dementia, crucially, is not part of healthy aging. It is a pathological aging. It is a disease. Part of the reason why the funding for dementia research has lagged behind other health challenges such as cancer and so on is because there's this perception that you live long enough, you're going to get dementia. That is not the case. This is a disease or a set of diseases which should be prevented and possibly cured. Now, as of 2015, when this statistic was taken, 60 million people worldwide live with some form of dementia. Of the 60 million people worldwide are experiencing some form of dementia, with 60% of new cases occurring in developing economies. Now, as these economies hopefully transition into more mature economy, more advanced economies, with the corresponding increases in life expectancy and the improvements in healthcare, the proportion of elderly people in these countries is only set to increase. Age is the single biggest risk factor for Alzheimer's disease, and so therefore, correspondingly, the proportion of people with dementia is only going to increase as well. And this is not just a horrible, horrible disease, it is also an economically crippling one. As of 2015, again, currently, or as of 2015, 1% of global GDP is spent caring for those with dementia, not including the hours of unpaid care that families and friends are giving to help their loved ones out. And again, this figure is only set to increase as the proportion of elderly people increases. Bear with me. Now, Alzheimer's disease in particular has what we call a long prodromal stage, whereby the neuropathology can exist in the brain for weeks, months, years, and sometimes permanently without the corresponding cognitive deterioration that we associate with dementia or Alzheimer's. Okay? This state gives us an opportunity to say, okay, if we can predict who is going to decline and who is going to stay in that state where they have the neuropathology, the problems in the brain, but they do not have the cognitive deterioration, if we can differentiate who's going to get dementia, who's not, then we can ideally implement interventions in order to delay the onset of the disease or possibly prevent it entirely. And that's interesting because a recent study suggested that actually 40% of Alzheimer's disease is preventable. And there have been studies in Finland. There's one ongoing or recently completed at UCL. There's papers suggesting that specific factors such as diet, the Mediterranean diet from Shannon et al. 2023. These studies have shown with the right interventions, we can guard against, we can allow someone to have a protective shield against the onset of dementia. Okay, so what is holding us back? There are 5 main challenges in clinical prediction modeling in general and Alzheimer's disease prediction in particular that are holding us back. First of all, the, what's the word? Over-reliance on unrepresentative data. A recent study by Borchardt showed that neuroimaging prediction studies in Alzheimer's research, 80% of them rely on a single data set. That is the Alzheimer's Disease Neuroimaging Initiative, ADNI. Most papers in this area use data that is very similar to ADNI, which is overwhelmingly white Western, something like 80% white, exclusively US-based in the case of ADNI. The ELSA dataset, another common dataset, is entirely England-based, Whitehall study, etc., etc. So thinking back to the fact that 60% of new dementia cases occur within developing economies, which are predominantly non-white, we can see that actually we are not building models that represent the people, the majority of new people who might benefit from them, okay? Another issue is bad methodologies, reporting and validation. So the majority of papers use unrepresentative data. Majority of papers only use one data set. There is no attempt at validation with external data sets. Some papers do not report how they handle missing data. Some papers do not report how they handle imbalanced data. There is a wide sweep of the quality of reporting and methodologies used when building these models, such that it is very difficult to replicate them, very difficult to externally validate them. And so therefore, if we can't do that, there's no way in hell they're getting into healthcare, because you need well-validated science, one would hope, that would equate to healthcare practices. So another issue is the lack of explainability. Now, if I come to a doctor and say, that woman's going to get cancer, the doctor's going to be like, how do you know? I can't just point to my model and say, the model told me so. It's not good enough, right? So doctors, in particular in healthcare, need to know both how good the prediction is, but also where the prediction comes from. And increasingly, as we use increasingly complicated modeling techniques such as transformers, the thing that underpins ChatGPT, deep learning and so on, it becomes increasingly difficult to understand how those predictions are reached. But this comes back to another issue, which I've been thinking about today, data-driven versus data-informed decision-making, okay? Now, a naive belief in the application of artificial intelligence is that we can just simply press a button, we will get a prediction, and we will blindly follow it. Now, I don't know if you've been following the post office scandal. That's a bunch of whole stuff happened in that scandal I'm not going to get into, but that's a very good example of someone just blindly following what a computer says, okay? I don't know if you've ever tried to code by just blindly following what ChatGPT tells you to do. I did that for one of my papers because I was feeling lazy. You just end up in a circle, man. Like, it's maddening. In healthcare and in a bunch of different other industries, it is not acceptable to simply blindly follow a computer, okay? Clinicians are always going to want to be have the final say on predictions. And they're always going to want to know how those predictions were reached. Now, another issue is the lack of obvious usability in existing clinical practice. Okay, so you built your model's great, it's extremely predictive, it predicts who's going to go on to develop dementia, but it's a convolutional neural network model or it's a transformer model. It takes 3 days to run on a very, very serious server or a whatever high-tech stuff, and then you're sort of expected or hoping that it will be embedded in the practices of the NHS, which, like, when I was volunteering there, they were still using Windows XP well after Windows XP was not being used anywhere else, okay? This is bear with me, I'm still trying to catch my thoughts. The model that you build, you would hope would have an obvious usability and an obvious way to be slotted into existing healthcare practices and infrastructure, okay? So you want it to be user-friendly, to have those explainability components, and in a way that clinicians can easily access it. You want to take into account the fact that, okay, is it really appropriate that if someone puts in their data, they get their prediction back in 3 days? Is that fast enough? Are we really expecting this model to be successfully embedded in healthcare practices, ideally as advanced as, say, North Europe, or, you know, as still, you know, as I'm trying to be PC here, some more economically less advanced healthcare services, that's what I'm saying here. Finally, the limit of the data available and the expensive and time-consuming nature to collect more. Now, things like the ADNI data set is a cohort data set that has been collected over years and years. Because of the longitudinal nature, the progressive nature of Alzheimer's disease, the collection of this data is often expensive and time-consuming to do, okay? Thus, there is a finite amount of data, very unrepresentative, and so therefore, this limits the amount of research that can be done at any one time, and generally, the data that generally progress is slowed down by that, and generally the data that is used tends to be the same data sets over and over again. So there are proposed solutions that I'm going to be discussing current work that has been done by myself and future work that is still in the pipeline that addresses all of this. So firstly, there has been an acknowledgement within the field that we have unrepresentative data, okay? So attempts have been made, and indeed have happened, where studies have been set up, for example, in India, the longitudinal aging study of India, which pleasingly has the acronym LASSI, if you know your Indian drinks, has been set up to collect data from a supremely underrepresented population, the 1.5 billion people in India that have been completely ignored in the data set up till now. It has also been designed to be harmonized to data sets such as the ELSA, possibly the Whitehall study, such that you can build a model on this data, on this hitherto unrepresented population, and validate it on the White Western data, or vice versa, okay? There are also ongoing studies in Bradford and East London run by Dr. Tim Rittman of Cambridge, and also the Queen Mary in Queen Mary University of London, to engage and collect MRI and other neuroimages from South Asian communities within Bradford and East London. These are still Western communities, but obviously the non-white aspect expands the diversity there. Now, bad methodologies. There are a group of researchers who have banged the drum about the poor methodologies, poor reporting within this domain. And as such, that same group of pedantic researchers have come up with the tripod guidelines. Now, these address clinical prediction modeling in general, but they are literally a checklist of what you should be hitting when you are conducting this research. You know, making sure that it can be replicated, making sure you are reporting how you're dealing with things like missing values, imbalanced data sets, you know, that type of thing. Now, the tripod guidelines are addressed more to clinical prediction modeling in general, but the tripod guidelines for AI are still pending and have been drafted, so they are on the way. But both sets of guidelines are applicable to artificial intelligence papers. Okay, so we can talk about the lack of explainability. We can talk about SHAP values. Now, SHAP values have been considered in recent years to be a way to lift the lid on the black box methodologies, such that we can have values associated with predictors that say this predictor was, just hit my step count, this predictor, that's why I do it, this predictor is important at this point when building this model. There's a question though. There's some nice visualizations that you can do with SHAP values, you know, to determine, you know, to illustrate predictor importance in model building. But I'm assuming most of you are working in industry. You will know that when you are trying to convey information, when you're trying to communicate to your stakeholders, different people need different stuff to understand what's going on. And the challenge still remains with SHAP values. It's all very well presenting that to me because I will understand what the SHAP value represents. But actually, if you present it to a clinician, clinicians are very, very smart people, but they're not trained to understand AI terms, are not trained to understand AI numbers in that sense. And so therefore, there is more work to do to bring the concept of explainable AI to explainable for specific stakeholders, okay? Another aspect we can look at is the focusing on methodologies with explainability built into them. Now, very, very complex artificial intelligence models are very in vogue right now. For example, transformers, deep learning, and so on. But actually, going back to the sort of traditional machine learning things such as random forest has an inbuilt way of stacking your predictors such that you can create a visualization and that says this is how important each predictor is, or was when I built this, when the model was built, and when these predictions were made. Okay. Okay, so we can talk about the lack of obvious usability within existing healthcare practice. Some of the work that is now starting to develop is focusing specifically on electronic healthcare records. Now, did the NHS have its 100-year anniversary this year, or was that last year? Actually, it's only January or February. It definitely had some sort of anniversary. Anyway, it's sitting on hundreds, like years of data, right? And the electronic healthcare records are a new avenue that, if tapped into successfully, allows us a more easy approach to apply these models, build these models in a way that can be more easily usable within the healthcare setting, because they're not relying on slightly artificial cohort data that has been created, but rather going directly to the source using medical records. Obviously, there are ethical considerations for that. The records would have to be fully anonymous and consent and so forth. But actually, this is one way where we can introduce usability almost from the get-go by the choice of the data that we use. There are also other aspects. For example, there have been papers, specifically one, my colleague Magda Bachok, which build proofs of concepts in order to demonstrate, look, we built this model, it's pretty cool. We have also built a proof of concept. Now, again, I'm assuming everyone here works in industry. Proofs of concept are pretty standard when you're building models. Totally unheard of in healthcare literature and particular dementia prediction literature, okay? Introducing those proofs of concept allow people to say, look, this is how clinicians will use these models. We will spit out prediction. We will spit out some really nice visualizations. We will also demonstrate how confident we are in the predictions and the risk score. So building in those proofs of concept needs to become more commonplace in order for us to successfully embed these models within healthcare infrastructure. And then finally on this point, survival machine learning. Now, classical machine learning or deep learning or AI, they tend to have if you're talking about classification, they tend to have a binary outcome, okay? Will a person develop a disease or not? Yes or no. Survival machine learning models the risk of developing the disease as a function of time, okay? So this provides two things. First of all, survival modeling has been around within the healthcare sector for decades, okay, since possibly the 30s, I think. This allows clinicians understand survival modeling better than generally better than machine learning or deep learning, but it also provides them more information. It provides them not only will they develop the disease or not, but a timeline of risk for that patient, okay? So that allows a more obvious way that the clinician can talk to the patient and say, this is your risk across time. And that's more easily understood than you might get dementia at some point or you might not, right? Finally, limited data and expensive and time-consuming to create more. Now, recently, there has been a move to try and create synthetic data using generative adversarial networks. How am I for time, by the way?
Oh, you're fine.
Oh, sweet.
Yeah.
Okay. You looked at your thing.
No, I think you're various other things. You're perfect. Don't worry.
Okay, cool. I'm not talking too fast, am I? You weren't too sure, but. So creation of synthetic data. General adversarial networks have had some success in creating these sort of artificial, entirely synthetic neuroimaging images, right? And so essentially we're spinning up data from almost nothing, okay? So they removes the expense of obviously collecting this data over years and years and allows us the opportunity to advance the field faster by creating that synthetic data. Now, there has been some work in tabular, longitudinal medical data of the type that I tend to work with that has been collected over years and involves several different predictors from different modalities. That has had more mixed results, but at the moment I am working on a model which will do exactly that. Once the data is created, it will then be taken and used within survival deep learning or survival machine learning work. Okay. So to conclude, I just wanted to outline, I guess, what I'm working on in the future. I hope I'm able to convey that there are a number of challenges within healthcare in general in the successful adoption of artificial intelligence models, such that we can predict who's likely to go on to develop a disease. In particular, those problems and challenges are particularly acute for dementia prediction and Alzheimer's because of that longitudinal nature of the data, okay? What I am working on for this year, hopefully, if I manage it and still hold down a job, is the focus on those specific challenges in my own work, in particular addressing diversity within the data. I'm working on creating neuroimaging models which will then be validated on, hopefully validated on neuroimages from that South Asian community data sets that I spoke about. I am also at the moment attempting to, have created a variational autoencoder in order to build up the synthetic data such that we can use it within survival modeling. And then finally, lifting the lid on transformers. I modified a transformer, the models that underpin things like ChatGPT for survival. I'm just going to call it survival transformer. Lifting the lid on that by using a work coming out of Warsaw from a research group in Warsaw, which takes the concept of SHARP and applies it to survival-based modeling. So that has hitherto not been done since. So that is me. I'd like to thank you for your attention. Are there any questions?
Cool. We have time for a few questions. If anyone would like to ask Henry anything. One quick note, Henry, if you could repeat the question, whatever you ask you so people at home can hear, that'd be fantastic. Thank you.
So you mentioned one of the reasons, or one of the blockers for implementing the risk modelling in the healthcare industry was the clinicians' confidence in the results. As far as I understand, the most effective interventions for Alzheimer's are dietary and lifestyle. There doesn't exist any medicine that stops the onset of Alzheimer's or significantly slows it. So therefore, if you're predicting someone that is likely to develop Alzheimer's and the treatment is going to be change your diet, get more exercise, that type of thing, the risk is very low. Why can't you, what's the reason for the healthcare industry not wanting to lower that bar for the confidence and taking this forward?
I think having confidence in the prediction is half the battle. I think there are other issues that have prevented healthcare from adopting. They also need to understand how the predictions were reached. These models, as one of my points, some of these models have not been successful. Actually, most of these models have not been successfully replicated or validated, and so therefore you're not going to get healthcare, particularly when the NHS has such robust systems for very carefully validating this work, very carefully adopting new health initiatives. That's why NICE and so on exist. They're not going to progress beyond that almost a prototype stage because they haven't done that. They haven't put themselves in a position where they can be validated and where their work can be replicated. So it's not just a case that the predictions aren't good enough. They are based on unrepresentative data. Their reporting is iffy. Their methodology might not be sound. It's not going to move anywhere fast unless these things are addressed. So it's all very well having fantastic predictions. You're going to go nowhere if no one can validate it, and you're certainly going to go nowhere if you can't adopt it readily within healthcare infrastructure. I completely forgot to do that. What was the question?
So I'm trying to understand the reason why the healthcare industry wouldn't want to take those results with a lower level of confidence if the treatment they're offering has a very low risk. I can understand if it was cancer treatment and they would be prescribing chemotherapy, which can be very harmful, then they need to be absolutely confident in the results. But if they're telling someone to change their diet and their lifestyle factors, then why not take some of these results from the models and give that advice to their patients?
Yep. So the question is, why would someone like NICE or some healthcare infrastructure not lower the bar for entry, essentially, such that because the interventions that you suggest that are out there have been shown to have some effect, don't have generally a negative side. Now, because I just answered this, but also just to add to this, there are generally Alzheimer's disease pharmacological interventions have not worked, right? It's only recently that we've had some success with a couple of drugs that came out, I think, last year, or the results came out last year. Now, these drugs have been shown to both reverse the cognitive deterioration whilst also dissipating the neuropathology, okay? But actually, when you look at the studies, it's in a very small sample, the effect size is very small, and actually the side effects are pretty horrendous as well. So the other aspect that you talk about the early interventions that have been shown to work were and diet and exercise. There are other things as well. For example, if you work in an intellectually stimulating job, if you socialize more, If you generally engage more with others around you, there's some evidence that video games play this sort of role in terms of logical thinking. If anyone's played Portal or Portal 2, that is definitely something I would recommend. I am terrible at that, but so there are other things that have been shown to work. But I agree. But that's not the thing that's stopping us. How good the prediction is not the thing that's holding us back. And so therefore lowering the bar for entry would not be sufficient in order to adopt these models into healthcare infrastructure. Oh my days.
Got time for 3 more questions.
Steve?
Henry, thanks for that. I mean, your passion for this subject really it comes through. But I want to ask you quite a simplistic, human-centered question, if I may.
Okay.
But it's fine. Because I didn't understand a lot of that, you probably know. But I did. But it resonated. So I'm interested in why, for you personally, this is such an important thing. Because it clearly is. Can I ask that?
Personal question, Steve.
I think there's probably a lot of people in the room that it's quite, that it has a personal resonance with.
So I originally wanted to do it, wanted to get into dementia research because it was a challenge that needed to be solved. Essentially, if we don't solve a lot of the age-related diseases, every single healthcare infrastructure across the world will collapse, right? So it was a challenge that needed to be solved. But because during my time when I was woefully underemployed and unemployed, living in the mean streets of Northumberland, I was volunteering with people with dementia, people with memory issues and Alzheimer's. And, I saw how heartbreaking the disease is. After a certain point, it becomes more heartbreaking for the friends and family than it does for the person, because the person ceases to understand what's happening, really. I've seen how poor some of the care homes are that people end up in. I've seen how poorly elderly people are treated in general. There's actually 2 books that inspired me. There's Atul Gawande's Being Mortal, great book, where half of it he deals with how he addresses how we respond to age, how we respond to people who get old. And the other one is Where Memories Go by Sally Magnuson, who is Magnus Magnuson's daughter. Magnus Magnuson used to present the other one, Mastermind, thank you. So her mother got dementia, and she charted very beautifully the struggle of caring for her mother while she was sliding down into Alzheimer's, And those 2 books, plus my own personal experiences, plus it's an incredibly difficult problem, and I just run headlong into those, is why I do it. I forgot to repeat the question again.
I forgot. So
he was asking for a personal story about why I inspired you. I'm joking, it wasn't that personal. What inspired me to get into dementia research? Sorry. Yeah.
When you repeat the question, please make a positive angle of what I'm going to ask. I don't express myself very well, but
Okay.
Very, very interesting, very inspiring. The thought that I have about the whole topic is that is there enough there to aim for? I'll explain. By which I mean, it's such a nebulous kind of ailment, if you like, that there isn't a target. With cancer, there's a target. There's markers, there's biomarkers, there's a tumor there, whatever. If you look at image analysis for Alzheimer's patients, yes, but that's probably way after everything has happened.
Yep.
So is there a target you're aiming? Because I feel we've got all these supercomputers, super software, super everything. We're throwing it, but what are we aiming for? I know we're trying to cure it, but that's the bit that I have. Please repeat it in a nice way.
I'm not known to be nice, so I wish I was joking. So he asked, sorry, your name? Alex asked, what are we aiming for in terms of the target that we're hoping to hit in order to either cure, or I would argue prevent is where I ply my trade. You talk about the target. There are well-documented neuropathology such as amyloid plaques and neurofibrillary tangles, which are essentially clumps in the brain, clumps of protein in the brain, misfolded protein, that because of the amyloid cascade hypothesis, we believe that causes that cognitive deterioration. So there is something tangible there. It's more complicated than that, obviously, and it's not clearly understood. But that is something that we aim for. And, you know, I spoke about, I use dementia and Alzheimer's interchangeably, which is woefully incorrect, and it's a bad habit that I think everyone does, because dementia is an umbrella term for a number of syndromes. Alzheimer's disease is the most common, but there's a whole host of others, and they all sort of tend to intermingle. There's no clear-cut thing, okay? So actually, pure Alzheimer's is, I think, probably fairly rare, but there are things that we know about Alzheimer's disease, things that we can look at, things that we can take. We can take samples from a person, spot that they have a buildup of amyloid plaque, for example, via lumbar puncture or via a blood test, and say, okay, that is a biomarker. We know that's a biomarker because umpteen amount of studies have correlated that with Alzheimer's disease. For a better example, actually, sorry, too long answer, is the ApoE4 protein, gene, which has been consistently shown to be a risk factor for the onset of Alzheimer's. Now, sorry, final point. Marvel Cinematic Universe, one of the 50 million actors called Chris, who star in that, he released a statement that said, I have been told that I am particularly susceptible to the development of Alzheimer's. I'm going to go hang out in my mansion and come up with a plan to prevent this. Now, I don't know, but it is likely that he was told that he has a particularly high amount of expressions of that ApoE4. So therefore, there are things that we can look at.
Thank you.
Yes?
I have a small question. Thanks for the talk, by the way, great talk. I have a small question regarding the percentage of new cases. Where does it come from? You were saying like 60% come from the developing countries, right?
Developing economies, yes.
Yeah, developing economies. So I was thinking, isn't that more concerning for actually the developed economies? Because so 85% of the population actually live in the developing economies. So 85% contribute just 60%. Means that 15% contribute 40%. So isn't the developing countries in some cases doing better in dementia? Is there a reason for that?
Yeah, potentially, yes. Again, I go back to Atul. Oh, yeah, thank you, sir. By the way, there was some quick maths going on there with the very quick maths. Your name, sorry? Ahmed? Ahmed, sorry. Ahmed was asking why developing countries appear to be doing better in dementia emergence than perhaps more Western countries. Now, I go back to referring to Atul Gawande's Being Mortal, where he talks about the differences in approaches to how we treat the elderly. My flatmate is from India, and the way that they approach family and their interactions with elderly members of the family entirely different to the way that we approach and interact with elderly people in the West, particularly in the UK and the US. In India, as I understand it, their care homes aren't really a thing, right? They tend to sort of absorb into the family. And when I was talking before about those social interactions and keeping you mentally stimulated, that almost certainly plays a key part. The cultural differences between somewhere like India and somewhere like the UK will likely have an impact on the prevalence of dementia cases. But there's also cultural implications for how people recognize dementia. You know, some cultures may not recognize it at all. Some cultures will just say, oh, that's just part of life. We'll just adapt around that rather than it being pathologized.
Yeah, maybe some of them actually don't get reported
Yeah, 100%. And yeah. So.
Also, I actually, something else that came to my mind was, maybe because in developing countries also not many people reach,
Yeah.
high age. So if no one, for example, lives, that's not the case for any countries that I know, but let's say no one lives till 60, for example, probably there will not be many cases for dementia because it's unlikely that anyone gets dementia before
Yeah,
the age of 60
yeah.
or 70. So.
Do we have time for?
We'll take one more.
Okay. Oh my, can you choose? I can't.
Now you talk about different cultures. Have studies been made about, let's say, not just the lifestyle, but the type of food they have as well, as compared to,
Yeah, so that paper I cited, Shannon et al., the Mediterranean diet. Sorry? Oh, I have not done this at all without. The question was, thank you. The question was, have studies been conducted to show the difference in diet and how that might impact dementia onset, the prevalence of dementia? So there have been studies, the Mediterranean diet by Shannon et al., kind of been 2013, because anyway, recently, have demonstrated that the Mediterranean diet has shown a predictive impact on or predictive cocoon, bad word, against dementia. But actually, coming back to the lack of diversity within the data sets, vast swathes of the world have not been studied at all. If we go back to India, no one studied the impact of eating that fantastic food on dementia. Okay, and so therefore, when we start to address the diversity within the data sets, we will start to understand a bit more about these potentially modifying aspects. Thank you.
So our next speaker this evening is Jackson Gabbard from Cord, who's talking about why vector embedding is so absurdly useful. So without further ado, Jackson.
Hey, all right. Hello, folks. I just realized I left something in here that I ought not to have left in, so I'm going to delete that. You never saw it. You never saw it. Hi, everybody. This is a packed room. Oh man. Okay. So I'll just dive right in. We'll start with the exciting bit, and then we'll sort of introduce myself in a second. The year was 1536, the year of our Lord. I'm sorry. Actually, it was the year 3072. The thing is, I wrote this before OpenAI released their newest embedding models, so they kind of messed up my joke. Anyway, we'll come back to these numbers. TLDR, we'll come back to these numbers. So the reason that I'm here is because I work for a company, we're Cord, this one. We build a chat and notifications. I'm a product engineer. I'm a software engineer by background. I'm not a data person per se. But we had a problem because we wrote documentation. We actually did it. We sat down and we wrote it for our stuff. Oh no, spoilers. So we wrote documentation, but it led us to the problem that people couldn't find the documentation that we wrote. And that's sad. So what do you do? What do you do? You've got all this good, tasty, delicious documentation that your engineers have painstakingly written. I mean, raise your hand if you're a software person, if you write code at all. How much of your day do you love writing documentation, right? It's a lot fewer hands on the second pass there. Yeah, so it's not your favorite thing, but we got them to do it. What do? So you use Elasticsearch, right? You could. You certainly could. But you may have heard about the shiny new thing. Oh. Oh. Yeah. So what we did was we went about building an embedding vector-driven search for our docs. And we did it. Like, I don't know, we're a messaging platform, right? You can put chat in your product. So what if you need to like delete a message? Wait for it. Look at that. This is from our own scraping of our own docs, plain text generation, chunking, vector generation from that, computing embeddings. You get the idea. We didn't pay Algolia. We didn't use Elasticsearch. Literally, this is just some stuff that we wrote. It runs in CI. Pretty sweet. So that got me hooked. From that point on, I was like, I'm just going to go as deep down this rabbit hole as I can possibly go. This stuff is ridiculously cool. So let's talk about how it works. I want to make sure I dial this in. I got a lot of hands up whenever I ask, do people code? So I think this is a codey crowd. I think I can safely do. How do people feel about seeing stuff on the terminal? Okay, I'm among my people. Oh, show of hands, I got ahead of myself. We are one. Thank you. I'm excited to be here and to talk through this stuff. So I just want to say, we're talking about embeddings, not this kind of embeddings. This is not the kind of embeddings that we're describing today. We're talking about this kind of embeddings. So an embedding, if for the uninitiated, which there might be 0 of, but just to establish a baseline, an embedding is when you take a string of text. In the LLM world, that's the world we're talking about here. You take a string of text and you tokenize it. You turn it into the little bitty tokens, and then you take those tokens and you map them into super dimensional space. How many dimensions? I don't know, ask Sam Altman, like a bunch. It's a huge, like gigantic dimensional space. What you get back from that is a list of floating point numbers, 0 to 1 numbers in a big old long list. One of my items on my to-do list here is to show you an embedding vector. So here's one. Here it is.
So is it a column vector or is it a row vector?
It's a single dimensional vector, so you decide which way it goes. This one's in a column. Hang on a minute, here's the best bit. Here it comes. There's the best bit. It's just numbers. It's just long numbers. How many numbers? 3,072 in this case. This is using OpenAI's newest text embedding large, which is just a gigantic, huge, huge long vector. So there we go. We can tick that off the to-do list. Nope. There. Nice. OK, so that's what a vector is. What are they good for? What are you good for? Prove your worth. Well, I'll tell you one thing. It's far more than keyword search. Like, we used it on our site to do search, semantic search. But it goes so much further than that. Oh, yeah. Oh, I already spoiled it. How many numbers are in the vector? Well, it used to be 1536, and now the bigger one. Anyway, the OpenAI ruined my joke. Yeah, these are the numbers you should keep in mind. This is how big these vectors are. They actually have smaller ones as well. But so why are they useful? Well, they're useful because of geometric distance. Raise your hand if you know what cosine similarity is. There's no shame in the game if you don't know. OK, good. There's some education happening here. I didn't come here to tell you all stuff you already know. So cosine similarity is this in math. Basically, you take one vector, and you take another vector, and you say, in the dimensionality space of the two of you, how close together are you? You don't believe me? I'll show you. By golly, I'll show you. So I wrote a little example code here. This is, oh, was that the next slide? Yes. Look at that. TypeScript here, JavaScript there. Choose your poison. This is cosine. I need to move that over. That is just right up in my, right on top of my head. OK, you go there. There we go. This is cosine similarity. You got your sort of vector dot product normalization function here. And anyway, you can math. What do you do with it? Well, you can take a vector like this, and you can say, like, how similar are you to a vector like this? And similarly, or dissimilarly as the case may be, how similar are you to a vector like that? So let's just see, like, how does it work out when you run this code? This is called cosine. No, it's not. What is this called? Simple cosine. Well, would you look at that? Why did it? Oh, because I run it again. So what this is saying is 1, 2, 3, 4, 5 is remarkably similar to 1, 2, 3, 4, 6 in 5-dimensional vector space. But 0, 0, 0, 0, 6 is a lot further away. Ta-da! We did simple cosine similarity. Okay, to the terminal. Well, so we're just going to go terminal from here forwards. What can you do with this, though? So we're just comparing the distances between numbers here, like 0.66 versus 0.99. What's it all about? Okay, yeah. Well, it turns out you can do some very interesting things with it, like different types of string comparison. Here's an interesting thing. In most string comparison functions, when you learn programming, there's a handful of different functions that let you compute the distance between strings, and they typically resolve around edit distance. So anyone want to shout out which two of these has the closest edit distance? I heard a whisper from the back. Someone's got to be braver than this. Come on. So water and waiter are the closest two here. This has 2 characters difference. This has 1 character difference. So you would think that these two should have the closest vector value, but will they? What is the name of this function? File string comparison. I'm calling OpenAI here. Please, internet, don't fail me. What? Let me just move this up a bit for you folks. Does anyone want to venture a guess as to why this is what it is? I heard semantic a bunch of times. The large language models use a semantic space. It's a hugely, crazily dimensional semantic space. So what it's telling you is like the meaning in a sense. Like if the LLM is doing what the LLM designers think that it's for, they're still discovering what it's for, but what they think it's for, it should tell you if something is meaningfully similar, the number is higher. And that's what we see here as well. Like waiter and water don't have that much to do with each other, except maybe a waiter brings you water, but I don't think that's meaningful. And a watcher and a water, I guess you can like watch a pot of water boil. I don't know, there's not much there, but ocean is literally water. So there you go. Nice. So there's some simple string comparison stuff. But it goes so much deeper than this, like so much deeper than this. Let's talk about another more interesting example. This code says, I'm so happy I could cry. Happy, and I'm so happy I could cry, sad. So what do we think is going to happen when we run this? Oh, come on, internet. There we go. It's this one. Would you look at that? Just the sentence and the sentiment have some affinity, some sort of meaning. This is because the semantic meaning of this is remarkably close to happy. Well, not remarkably close, it's somewhat close. It's certainly closer than the word sad, which is fascinating because it has the word cry in it. Crying is a sad thing a lot of the time. And yet somehow the multidimensional, yeah?
Sorry, why is the number so low? Why is the number so low still? When actually meaning of the sentence is that they're really happy. So given it
I don't know. There might be someone here who does know. Ah, okay. The question was, how come the number is so low since the meanings of these are so similar, semantically related? You'd expect it to be a higher number. I think, is this the question? I don't know. I don't know. The multi-dimensional vector space of this is something that like only AI researchers who literally worked on this model will be able to articulate. It could be something like the length of the string or the grammatical structure. Like there's a bunch of parameters in this model. It could be that one is clearly a sentence, whereas the other one is just a word, and that puts them a little bit further apart. There's a zillion different factors that go into this that are hard to anticipate. Nice. So that's sort of deep semantics. But like, we haven't even scratched the surface of how cool and how useful this stuff is. One of the things that I was thinking about whenever I got into this was like, when you go to LinkedIn or Facebook and you type in someone's name, you get like a list of results back. Like, where does that come from? How did they decide what it is? And it turns out they use a bunch of different graph things. I should have mentioned this earlier. I used to be a Facebook engineer. I worked there for a long time ago. It's been gone a long time. But Facebook uses a system called coefficient. And coefficient is how it figures out who to suggest to you. But then there's just like a simple string comparison problem. You type in a name, and then Facebook has to turn that into the list of people that you might want to know about. That's really hard. There are data structures that help you with this. There's things like trees and retrieval and skip level and one misspelling correction. There's a bunch of different algorithms and data structures you can use to overcome the fact that people are bad at spelling names of other people. But it's a hard problem. It takes senior engineers writing distributed systems, lots and lots of time and energy to solve this problem. But I thought, like, could an LLM, like could a vector, could cosine similarity do this? Maybe it can. So what I did was I generated a bunch of names. And I apologize for the lack of representativeness of this. The talk previously has got me thinking a lot about representativeness of the data. I went to Wikipedia and found like a list of names, and I copied and pasted that. So this is the Wikipedia list of names, and it's like mostly Western European names. And I'm like, yeah, I just ran out of time to do more than that. But what's cool about it is if I start typing a name like, I'll type my name. It's going to call out, it's going to get the vector embedding of my name, and it's going to go through this list. This list is like 1,400 names long. And it's showing you on the right side the vector similarity, the cosine similarity, and on the left side it's the name that came out of this list. The thing is, Jackson shows up as a last name in some of these cases, but what if I... It still works. What if I just completely butcher it? Oh, I get something different. But here's one that I was playing with earlier. There's some Portuguese names in here, like João. But if you hear it, it sounds often in Portuguese like João. So what if I just type that in phonetically? Still works. This is magical. Like, this is the kind of stuff that it takes, dumb stuff. That tilde means that character is not equal to an A if you're doing simple string equality. So if you're trying to build a system using traditional software to do this, what you have to do first is take any special characters and convert them into the ASCII representation of those characters that's like the vanilla, uninteresting version of that. And then do normalization on top of that, do your own sort of hand-rolled tokenization, and then map that string into whatever data structure you've put in place to fetch back the list of names with whatever rules and fault tolerance you allow. And like vectors just like, yeah, no, I got it. It was something like this. I find this totally mind-blowing. What's another example?
Holding the previous context as well, right? Because in the previous search you probably have searched which you are.
So the question was, is it holding context? Is it holding onto what I have done previously? And I heard some murmurs. I heard some murmurs from other people. Does anyone want to shout out what's happening here? You were brave enough to murmur, but now you're in the hot seat. Well, so I will say there's no shared, there's no learning here. It's every single time I type a new character, it is going and computing the vector of that string and then saying, across this 1,400 item list, how similar is that stuff? It's, yeah, that's all there is to it. And it is remarkably fault tolerant. Oh, there he is. Terry Rodriguez. That's exactly what I meant. If you imagine like autocorrect, if you imagine sort of the things that you can build on top of just a simple trick like this, it's pretty rad. Okay. Okay. I get the impression that a lot of folks in this room are data people. If you work with data, anybody here? Oh yeah, okay. So something you probably deal with in data a lot is surveys. Here is a list of survey responses to a talk. The person who gives the feedback and their feedback. This is the kind of stuff you get when you're doing data manipulation on the regular. So my question to you is, was it a good talk? Well, I don't know, right? And I'll be darned if I try to go back and read all of these. There was 61 responses here, and even if you read them all, would you know? Like, I don't think I would know. So what if we did something interesting like, let's see, I'm trying to remember the command that I ran earlier to do this. Classify. Oh no, I forgot the, I worked on this today and I forgot how I structured the inputs. Is it 2 arguments? Yeah, okay. So here's what we're going to do. We're going to do, I think I actually have this command saved. We're going to do this the old-fashioned way, where I hit up until I find the command. Maybe? Oh, if I No, I saved this, right? I saved this.
Wait for it to do a demo.
Can I not type? Oh, I see. Classification embeddings. And then where is the survey response embeddings? Comment embeddings. Okay. I got this. Classify. First thing should be comment embeddings, and the second thing should be the classification embeddings, right? Yes! Success. Okay, sorry. I very nearly botched this whole thing. So let's check it out. What I've done here is, if I kept my classifications, I wrote in a text file, I wrote in a text file, very positive, somewhat positive, neutral or indifferent, somewhat negative, and very negative. I just decided those were my classes. And then I said, what if I generated an embedding of each of these words? And that is classification embeddings. So this is, let me scroll back, I don't know, 3,000 or so floating point numbers. Shout if you see it before I do. There, very negative. So there's very negative, and there's its embedding. And then what I also did, before I got here, because the internet is a dangerous place, is comments. I took the comments, and I did vector embeddings of them. And then what I wrote was just a tiny little script. It's a very boring script. And what it does is it says, go over, how do I put this on screen where you can see it? Go over this file and take all of its embeddings, and then go over this file and get its embeddings, and for each one of these embeddings, compute the cosine similarity to that one, and add them up. Whichever one is the highest scoring one, say that that's what it is. So when you run this bad boy, what do you get? Well, you get the rating on the left and the comment on the right. And let's see how it goes. Somewhat positive, very informative, could be more engaging. It's like this talk. No, I'm trying, people. I don't know, what do you think? Is that somewhat positive?
That's bang on.
Okay. Let's try another one, maybe somewhat negative. Good effort, but the pacing was too slow for my taste. Ouch. Yeah, I think that's kind of like, yeah. So was it a good talk? Well, when you've got reasonably good summaries of these things, what you could do at the end is just add it up. So Chong, what we've got, oh, sorry, let me move that up so folks in the cheap seats can see. 27 of the respondents said something that vector space the LLM believes was a very positive comment. 9 said something somewhat positive, etc. So what do we think? Was this a good talk? Yeah. Better than right? Better than average. Yeah, there you go. This is the sort of stuff that you can do super, super easily with just like taking a comment. Yeah, go ahead.
See what? Because I was literally thinking about this because I was running semantic analysis using a model like yesterday and today, and what was weird was I was running it through a Hugging Face model, and I was getting different scores against the sentiments I was checking for, and I was like, first time I was like, this is amazing. I was like, okay, this sucks because it's like the probabilities were affecting the outcomes each time and then I was thinking, vector embeddings, there has to be a way to use this. What's really interesting about this is because you're just looking for positivity, but if, say, you're doing customer feedback, say you wanted to know specifically about how is my pacing, you can do a vector search for pacing, right? And see, like, actually, was pacing an issue? Was my tone? Was the content? So, yeah, it's a really interesting application.
So there's the comment there was around, like, if you want to do this, you pointed out several things. One is if you call the API with the same string twice, you will get back 2 different numbers because there's an inherent jitteriness. There's an inherent stochasticity to what LLMs give you back. It's fascinating. It's even more extreme when you send something to a completion API, for instance, and say, give me back. You have even less control. The vector space is much more restrictive. And you were talking about if you wanted specific insights from your talk feedback, for instance. Say, for instance, you wanted to know about your pacing. Well, there's a cool thing that you could do. Who here knows what HYDE is, or hypothetical document embeddings? Okay, excellent, excellent. Hypothetical document embeddings. It's where you, like if I were to search this document, if I were to give it to ChatGPT and say, tell me what people thought of my pacing, it will probably fit well enough into ChatGPT's context window for ChatGPT to be able to do that. But if I had 5 gigabytes worth of data over the course of several years and I wanted to know about pacing in that context, I probably wouldn't be able to find it that way. And also, people express this in different ways. People might say pacing, or they might say talk too slow, or talk too fast, or I was bored, or it rambled on, or there's a bunch of different ways to express that same idea. So one technique with vectors like this is a thing called a hypothetical document embedding, which is where you take what you think it might look like, and you create the embedding of that, and then say, can you find me stuff similar to this? It's a more advanced technique. This is what's used often in, if you folks have heard of RAG or RAG. This is one of the techniques, one of the more advanced techniques of RAG, and it leverages embeddings just the same. Okay, so classification we've covered. Now I want to end on a bang. I think I'm like, yeah, I'm doing okay for time. Random things 2. Now we're talking. I present you with a list of things. You're welcome. What is this list? Yeah, this list is on the crack. There we go. This list is off the crack. Just like that, we're improving the world. It's a list, and you sometimes have problems like this in data work or in all sorts of practical applications where you're like, what's the pattern here? What is in front of me? Turns out, LLMs, vector space, is actually really, really good for determining this. One of the other super, super cool use cases of vectors is clustering. You don't believe me? I'll prove it. Here is all of those same things with the n-by-n vector computation. I'm literally going and comparing the vector distance between every single one of them. And I'm mapping them into 2D space. And does anyone want to shout out when you find a cluster? Fruit. Countries.
Sci-fi books. Animals.
Sci-fi books, indeed. Mythical things.
Animals.
Animals. I think that's all of them.
Human and mermaid are close.
5 points to Gryffindor. You might know. Oh, here, let me move this up. Actually, sorry, I think folks in the back can't see it. I'll run it again, and hopefully it still looks good on the reduced screen size. So what I've done here is I've created a sort of a spring force D3 graph visualization of this, and the spring force is the strength of the cosine similarity. So what this means is as this thing jitters and stuff, what you end up with is things that are semantically related end up closer to each other in 2D space. And so, like, I didn't program this at all. I just said, like, hey, you tell me what the weights are between these OpenAI vector embeddings. And look at this. So we get this, like, nice, tight cluster of sci-fi novels. But we have this weird anomaly. How come 1984 is so close to Apple? Yeah. Right? Yeah, with the hammer throw and all that, the famous Apple ad. There's another thing that you just pointed out, which is you got all these fantasy creatures, but they're really, really close to the actual living creatures. They're much closer than, say, like a blueberry. So what we're seeing here is actually a reflection of the semantic space of the LLM itself. It's very constricted, right? It's this tiny data set, but we're seeing that. And the fact that all of the countries ended up all close together, and the animals ended up all together, and the animals and the fantasy things which are closer, that's just an artifact of, like, semantic similarity. But out of the gigantic list of stuff came clarity, came real clustering. So that's all I prepared, and I'm actually pretty well for time. So we can pause there.
Wrestle with my mic here. Give me 1 second. Sorry. I have to say that is the coolest graphic I've seen in quite some time. Yeah, that's amazing. We have time for a few questions from the room. I think you got one from Jamari immediately behind you there. Not to pick favorites, but.
Would this work for slang words?
Yeah. Oh, yeah. Yeah.
If you could repeat the question.
Oh, sorry.
Well, no, it's a common theme today.
The question was, will this work for slang words? So I don't know if you folks are frequenters of the Urban Dictionary. I have spent a lot of time in that space, both contributing and reading. And I have found consistently that ChatGPT blows Urban Dictionary out of the water. Earlier, I saw an unexpected video on Reddit. I think it was actually Abrupt Chaos. And it was a thing that happened in India. And someone wrote in phonetic Hindi a word that I will not repeat here. And I was like, what is that word? And this is, remember, this is not the Hindi character representation of this. This is the English phonetic spelling of a Hindi word. Plonked it in ChatGPT, and it's like, oh, hey, that's this word, and it's also super offensive. And it's like, oh, right, so I'm just going to not say that and not show you what the word was. But yeah, it absolutely works for slang. In the back.
I'm curious how you would go about, because in my previous couple of plays, we used to use a lot of like semantics and embedded vectors, but what we found really difficult is like evaluating or like coming up with metrics to go like how well you're doing, how well like the model is doing. Yeah, I'm curious to know like how, if that's something you consider or look at.
It's tricky. It's really, really tricky. So I actually took one of the items out of my list down here. It was anomaly detection. Because of this, I took a bunch of things that were sort of identifying information, and I did the vector with the word, with the string phone number. And sure enough, the phone numbers give you a higher cosine similarity to the word phone number than like an email address or the word banana or whatever. So it kind of gives you this vague sense that like, oh, this could work. Like I just tell it what it is, and it tells me how similar it is. And then I typed in the word phone call, and it blew everything else out of the water, because the rest of the semantic space is still there. It's tricky. It's really, really tricky. And I have no silver bullets. Yeah, if you're going to use them, you have to know if you are using them in one of the ways that they are good for. And the list is actually quite short. Clustering, anomaly detection, search. There's a short list, basically. I can post a link in the chat. Where am I? What, are you Twitch streamer? There's a limited list, most of which has been represented here in this. Yeah, go for it.
You know this vector embedding stuff, like would say different companies do it differently from others, like let's say OpenAI compared to say Datasparq or something like that. Would they do the embeddings differently, and therefore the semantic spaces would be similar but not the same?
Yes, probably. The question was, do different companies do the vector embeddings differently? Do different LLMs do the different vector embeddings differently? There's some inherent similarities in just how LLMs represent data. That, they have to be vectors of numbers because that's how all the GPU acceleration and stuff works. But if anybody here is like an ML research engineer, you know the answer better than me, and feel free to shout out and enlighten us.
I wouldn't know the answer, but I can say
By no means.
Who's the engineer?
There's a leaderboard. There's a leaderboard for embeddings.
Ah.
So there's free models and then there's paid. So OpenAI has released Text 3 Large, the one which is like the new one, which is 3070, which is supposed to be very interesting to a lot of people. But there's lots of different ones, and yes, they do things differently, and they will affect how well they perform for things as well. That's as much as I can say.
And if you use one for embedding your data, you can't use another embedding to embed the other. You have to. So that's why. In other words, yes, they are different.
Yeah, so if you take the cosine similarity of a vector from one LLM and you use a vector from a different LLM, you have randomness. I do not think that they are intelligible to one another, yeah.
Also, the databases you use can be different as well. So if you use like one vector DB can give you different performance to another one. So it's cool. Like you can go to it and have a lot of fun, like experimenting. Then when you kind of maybe look to do production, that's where some of the bigger questions around performance also come into it a bit as well, I think.
I think following up from that question as well, if two or more LLMs have different semantic meanings, would there be like a metric to differentiate the semantic meanings, or would we have to look at either the training data or how the different words or phrases or characters are tokenized in networks? Is there like one metric that tells you that, okay,
Not
LLM1
between them, not between models.
So the question for folks playing along at home, the question was, is there a metric was it for determining the difference in semantic meaning between things?
Yes, across LLM.
I think cosine similarity or something equivalent, there's a couple of different geometric measures between them because it's an n-dimensional space and you're mapping similarity between them. As far as I know, that's the state of the art, but hashtag I am not a machine learning engineer.
Not within the same LLM, between different LLMs. Every, there would be like a cosine similarity across the LLMs, but as I think it was rightly pointed out, no two LLMs vectorize and embed stuff in the same way. Hence, they have different semantic meanings. So I was just thinking, is there a way to either quantify that difference in semantic meaning, or is there a way to visually present it like a graph? Like let's say one LLM could have a different graphical representation of a semantic meaning than another could have.
Just in case anyone gets the idea that I'm a machine learning specialist, I'm not. However, I do know a few things. So to get to the embedding stage of the model, you use a number of other models to build it up. And the whole skill, OpenAI has its own set of engineers and everybody else has their own, is they build those things differently. So the numbers you end up with for a vector would be totally different. The relationship might be the same within in the interpretation. But the building process is totally different. That's why OpenAI has an edge, and that's why Grok does something different. Is it Google Grok?
That's X.AI.
Yeah.
Twitter now call it.
So that's the IP part of all of it.
To summarize for the folks at home, different LLMs do it differently.
Yeah. I agree, like the recipes might be different, but like there might be like just one overriding factor. Let's say I don't know, mom's recipe tastes 10 times spicier than when I make it, for example. So like I think I'm thinking far ahead. I'm just thinking if there's like one factor to figure out the recipe base.
And there was one more question towards the back. Hey.
Is embedding a quick way to assess how, dare I say, accurate an LLM is or knowledgeable it is in a certain area, whether that's visually or just looking at kind of the nearest neighbor percentage it comes out with for a very niche area?
You could use it to, probably not. Yeah, probably not. The question was, thank you, the question was, are vector embeddings a way to sort of measure the quality of the LLM, if the LLM is sort of doing it right? And I think probably it's not. The world is still discovering how to evaluate LLMs, and there are some extremely complex measures, mostly like putting them through tests to see how humans do at those same tests. You can use you can use vector embeddings to determine if you will be able to use the model to do your particular task, for sure. But I would be very hesitant to try to say, because we got good grouping between these things, it must be a good model for some definition of good. I don't think so. Hashtag, I am not a machine learning engineer. So the question was, do we lose anything by taking a high-dimensional vector representation of something and putting it into something simple and two-dimensional like this? Well, I've got a trick. There's actually 3,000 layers, and they're just stacked really thin right on top of each other. I'm just kidding. That's nonsense. The thing is, this is human consumable. The human brain, we have our limited 2, 3, sometimes 4-ish dimensional understanding of the world. You got to reduce the complexity down to do something meaningful with it. So if you're trying to cluster something 2D, like you could do it 3D, but like we suck at reasoning in anything higher than 3D. We're really, really bad at it. Like if you've ever tried to like understand what a tesseract is just by the diagram, you're like, nah, I got nothing here. That's just a square with some extra lines on the outside of it. You can't fool me. So it absolutely is lossy. And also, I can't interpret a 1,500 dimension vector personally. It's a fair question. Time for one more. Time for one more. One more. Make it a zinger. Oh, sorry, it could be okay. There's a brave man in the back. So the question was, which model are these? This is using the new, hot, fresh off the presses OpenAI Text 3 Large, the 3072 dimension vectors. It's the successor to their Ada 002 one, which they used for ages and ages and ages, and they finally released this.
What's the reason for choosing that model?
Because it's new and cool. I'll go back to. If you look at their published blog post about it, they say, I'm tethering for my phone, this might take ages. They say a bunch of things about how it's just semantically much more relevant. Here we go, no, yeah. So these are some of those tests. These are some of the benchmarks for quality. These are really sophisticated benchmarks. And you can see like the old Ada V2, it's just like, well, on this dimension, it's actually not massively better, but this one is huge. And there's a bunch of different ways to measure this. What does that mean? Well, it depends on what you're using it for. For a huge percentage of the cases, the old one will be just as good as the new one for like simple classification and stuff. But for deeper, more richly semantic stuff, the new stuff is just better. It's also way, way, way bigger. I mean, 1,500 floating point numbers versus 3,000 floating point numbers. It just doesn't fit in memory as well. You can't save it to disk as well, blah, blah, blah. Hashtag scaling stuff.
I suspect it's cheaper as well. Normally get cheaper.
The new one is cheaper or the old one's cheaper?
Normally the new ones are cheaper. I don't know.
I don't know.
I'm wrong.
I think this is more expensive. Anyway, that is my time. Oh, quick. So I'm Jack from Cord. This is cord.com. I'm here, and Hannah is here as well. We're both here from Cord. little plug. If you're interested in chat and notifications, if you build a product and you want to give it a collaborative surface, that's what we do. And we'll be lingering about. This is my email address if you want to hit me up afterwards. Cool. Thank you.
Thank you, Jackson. That was awesome. I think fitting to have a thing in there about the comments received from previous talks, because moderating the chat as I watched, seeing very similar comments coming in positive directions. It's great stuff.
Hey.
Right. So we're no longer on the break.
Oh,
We're having a slight change to the agenda. We're not going to have our last talk this evening. But very quickly from me, before we wrap up, a little bit of housekeeping. So our next event, very exciting, is on the 14th of March. It's going to be at Datasparq, which is just down the way. So if it was convenient getting here this evening, you're in luck. The 14th. The 14th. Thank you. I can't read. Our 14th event is on the 13th of March. Thank you very much, sir. A very quick thing from me then. We have some space in the Christopher Hatton, which is just down the road. If you're wondering where it is, the link is in Meetup for drinks after the event. We have a hard out at 9 because we have to put all these chairs back. So if you could make your way either to home or to Christopher Hatton or whatever you want to do, you're grown up, you can do whatever you want. By then, that would be great. One very last thing, this has been our biggest ever event. Thank you everyone for coming out. This has been very exciting. Give yourselves a big hand. Thank you everyone watching along at home. It's not quite as, the vibe isn't quite the same, but we're glad to have you all the same. I always say one final thing and it's never the last thing. If you could send any pictures you've taken this evening at us on LinkedIn or at Meetup, that'd be amazing because it's great to see everyone here. Definitely, thank you everyone for coming and have a good night.